Okay, I have to make a quick video here for you guys because I'm away today, and the video I made last time I taught this, the sound didn't work, so I have to make a new one. So today's lesson is on something called double displacement reaction. We've already seen single displacement reactions. All right, so you don't have to write this down, but just kind of as a reminder, right? Single displacement reactions is where we have an element like A, just chemical A, reacting with a compound like chemical B, C, and the element will displace an element in the compound. So again, if A is a metal, it will displace the metal. But if A was a non-metal, it would have displaced the C, the non-metal. And that's going to get us then a new element all on its own and a new compound where A has taken the place of B. And so that is what we call a single displacement reaction. All right? I would have talked about it kind of like a dance where we have a couple dancing, and that couple then has someone cut into the dance, and then we have a new couple dancing. All right, so that's last day's lesson, and what we want to talk today about is then something called double displacement reactions. All right, now this lesson, and I'm going to continue now on to the next slide. This lesson is based on yesterday's lesson, and it has everything to do whether the substance that we produce, that new substance, is slightly soluble or insoluble, and then would form a solid. And so yesterday's lesson, we did some examples of where we checked some substances to see if they were soluble or not, and then if they were, they would become aqueous, and they would dissolve in water. Let me give you an example. Again, you don't have to write this down, but if you recall from yesterday, if I have something like sodium chloride, and I check that on my solubility chart, all right, and we have a solubility chart here. It's on my next slide. So if I check it on my solubility chart, you'll see that sodium and chloride, when I get to that particular spot there, sodium and chloride is aqueous. There it is right there, aqueous. And what does that mean? That means it's going to dissolve. So again, if I take a look at the sodium chloride, it's aqueous. It's going to dissolve, which means it's going to break into its Na plus ion, and it's going to be aqueous, and it's going to break into its Cl minus ion, and it's going to be aqueous. All right? And just to compare that with a different one, if I had something like silver chloride, all right, that's a different story. Again, if I look ahead at our chart, silver chloride, you can see silver has a lot of S's, and silver chloride is a solid. That means it does not dissolve. So if I go back up here and I take a look at silver chloride from the chart, that's a solid, which means it doesn't do anything. It stays as a solid. It does not break apart into its ions. It stays solid. So double displacement reactions, excuse me, double displacement reactions, when we do a double displacement reaction and it trades partners, if we get something that is a solid, it will stay solid, and we get something called a precipitate. All right? So a precipitate is whenever a new state is formed and it settles to the bottom. So if a solid is formed in something that is aqueous in water, then we say it precipitates out. It's kind of like when liquid is formed in our air, in our atmosphere, in the gaseous air, we say the rain precipitates out. So in this case, we're looking for solid precipitates. Okay? So once you've written that slide down, and you can pause the video in order to do that, I'm going to move on to the next slide. All right, so now I'm going to move on. And now let's do some double displacement reactions. All right. Now, these rules you see at the top are very good, but before I do that, I just want to write down the general formula for a double displacement reaction. I'm going to stick it in this spot, so you can write this at the top. The general formula. All right. In other words, this is the chemical equation or the chemical formula for all double displacement reactions. And so in a double displacement reactions, we always have a compound, A plus B, and it's going to react with a second compound, B plus C, in order to produce two new compounds. So in this reaction, again, the A is the metal, so it's going to displace the metal, which is the B, the guy at the front. So now we're going to end, oh, look at what I did. I've got a mistake. I got to fix that. Sorry about that. A plus B, sorry, AB, the compound AB, plus CD, the compound CD. And again, let me go back. A is the metal, and C is the nonmetal. Sorry, C is the other metal. And that means A will displace the C, and C will go in place of A. All right? So we're going to now have CB, a new compound, and AD, a second new compound. So how do you know if I'm asking you to tell me what type of reaction this is? You know because you have two compounds, and in the end, they produce two compounds. All right? So that's how you know it is a double displacement reaction. Okay, so how do we then complete our double displacement reactions? Complete the word equation. So you can see down here we have a word equation. So we're going to complete that by trading around the partners just like we did up here in this space. Sodium chloride and silver nitrate means I'm going to now have sodium with the nitrate and silver with the chloride. All right, and I ran out of space there. I can't get the E in there. I'll stick it down there. So we're going to have sodium chloride and silver nitrate are going to trade to produce sodium nitrate and silver chloride. Next, in number 2, determine the solubility of the products and the reactants. We're going to use our chart, all right? So we're looking at our chart at this point. Again, I want to move down. So we're looking at our chart, and I'm going to find the solubility of both the reactants and the products. So if I take a look at sodium chloride, you'll notice it's AQ, right? There it is. It's AQ right there. I'll put it in the corner. There it is. It's AQ, all right? Which means this is aqueous, AQ. Silver nitrate. Remember, I would have said yesterday that all sodiums are aqueous. Look at that. That's easy to remember. All sodiums are aqueous. Silver nitrate. Just above, silver, and over to nitrate. There it is in the corner. All right. Also aqueous. Excellent. Our reactants are aqueous. Now let's check the products. Sodium nitrate. Sodium nitrate just below, aqueous. Aqueous. And let's now check silver chloride. There it is there, just above, solid. So this guy down here, and I know I'm out of room, is solid. Okay? So we've determined the solubility using our chart. Now we can write a balanced chemical equation. Notice it says here, if a reaction occurs. All right? If the reaction occurs. What we mean by that is there a solid? Right? So in other words, is a solid formed? All right? That's how you know whether if a reaction occurs. And in our case, we can see silver chloride is a solid. So now to finish, we will write a balanced chemical equation for this. So we need to know how to do our formulas. NaCl, checking our periodic table, that's 1 and 1, and that's done. We write it down as aqueous. Excellent. Plus silver nitrate. Ag. We go to our periodic table, we find nitrate, it's on the chart on the back. NO3, 1 and 1, that's done. Also aqueous. Now the arrow, sodium nitrate. Na1, NO3, 1, and notice it is also aqueous. We found that on our chart. And finally, silver chloride, Ag1, Cl1, and it's a solid. And therefore, we, yes, have a precipitate, and the precipitate is silver chloride because it formed a solid. Okay? So that's how we know whether a double displacement reaction occurred or not. Let's do a couple